Good day, everyone! I am Teacher Rhea,
And I am Teacher Jelly.
and we are ready for this new lesson.
How about you?
Are you ready as well? And if
And
it's yes, let's go! Nice! But before we officially start our class for today, let us first glorify our class with this opening prayer. Let us all bow down our head and close our eyes. Dear God, our Almighty Father, Creator of heaven and earth, thank you for this gift of life. Another day to spend a meaningful chapter of our life and for learning another wonderful things. We ask forgiveness for we have sinned. May we recover from our lapses and have faith in doing good deeds. Guide us today as we embark in a whole new session of our math subject. This we pray. Amen.
I see that we are all excited today. And for that, I would like to know who's joining me all throughout this session. For our attendance, instead of saying present, when I call your last name, tell me a name of any objects with 4, 3, and no sides. Am I clear?
That was nice, Teacher Jel.
Indeed, Teacher Ray.
Okay, so what can you say about our students?
They did a good job.
Nice! And by that, they all deserve a good job applause. G-O-O-D-G-O-B, good job, good job. G-O-O-D-G-O-B, good job, good job.
And finally, presenting to you our objectives. I believe together, we can do this.
Teacher Jan, what can we learn from this?
And at the end of the lesson, you should be able to first define the triangles, quadrilaterals, and circles. Second is to enumerate and give examples of the types of special triangles, quadrilaterals, and distinguish the parts of a circle. Third is to appreciate the topic by interconnecting it to real-life situations. And lastly is to apply the knowledge by performing solutions using the appropriate method and formula and show creativity in performing the assessment. And that was all. We can do this together.
Hooray! Teacher Jelly already presented the lesson objectives. And I know and I believe that together we can do this. Come here, Teacher Jelly, join me. And this is Lesson 15, Special Triangles, Quadrilaterals, and Circles. Finally, we have to undertake first this pretest. And for our pretest, this is entitled, What Am I? For your instructions, you have your individual illustration boards. And what you are going to do is if you have the answer or if you already know the answer, you are going to draw your answer in the illustration board, and when I say go, you have to raise it. First, question number 1. I am a three-sided flat polygon. What am I? Raise your answer. Nice. The answer is triangle. Triangle is a three-sided flat polygon. Second, question number 2. I am a type of triangle with all my angles less than 90 degrees. What am I? The answer is acute triangle. Acute triangle is a triangle with each angles measuring to less than 90 degrees. Question number 3. I am a two-dimensional figure with 4 straight sides. What am I? So, the two-dimensional figure with 4 straight sides is quadrilateral. Question number 4. I am a quadrilateral that has exactly one pair of opposite sides which are parallel. What am I? The answer is a trapezoid. Yes, very good. And lastly, question number 5. I am a quadrilateral that has sides with equal length. What am I? Yes, a quadrilateral which sides are equal in length is a rhombus. Very good. And class, we are done for our pretest. And based on your performance, I can say that you are all doing very good.
Special triangles. Look around you. What triangular objects can you name? But first, let us define special triangles. Every triangle has 3 sides and 3 major interior angles. The measures of the interior angle adds up to 180 degrees. The lengths of each side must be less than the sum of the other 2 sides. We have in here a figure of a triangle, and we can see in here the 3 sides of the triangle with 3 interior angles. The 3 types of special triangles: the equilateral triangle, the isosceles triangle, and the right triangle. Equilateral triangle is a triangle with 3 congruent sides. The measures of the 3 interior angles of such triangle are also equal, and each measure is 60 degrees. We have in here an equilateral triangle, and equilateral meaning equal. And take note, all sides are equal. Next, isosceles triangle. It is a triangle with at least 2 congruent sides. If a triangle has 2 congruent sides, then the angles opposite of the 2 sides are congruent, meaning only two sides are equal. We have in here a figure of an isosceles triangle. As an example, just think of a slice of a pizza, right? Only the 2 sides are equal. For example, in triangle ABC in geometry figure on the left, the measure of angle A is 50 degrees, the measure of angle C is 50 degrees, and the measure of angle B is x degrees. Since both angle A and angle C have measure of 50 degrees, it follows that the length of AB is equal to the length of BC. Since the sum of the 3 angles of a triangle is 180 degrees, and it follows that 50 plus 50 plus x equals 180, and the measure of angle B is 80 degrees. Lastly, the right triangle. A triangle with an interior right angle. The side opposite of the right angle is called the hypotenuse, and the other 2 sides are called the legs. We have in here a figure of a right triangle, and we can see in here that line C is the hypotenuse, and line A and B are the legs that forms a right angle. In right triangle DEF, side EF is the side opposite right angle D. Therefore, EF is the hypotenuse and DE and DF are legs. The Pythagorean Theorem states that in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the lengths of the legs. We can derive in here the formula a squared plus b squared is equals to c squared. In our figure, we can apply the formula EF squared is equals to DE squared plus DF squared. Let's try our understanding. So, find the missing value of x. And we have here the given 5 and 8. 8 squared is equals to 5 squared plus x squared. 8 squared is equals to 64 equals 5 squared is equals to 25 plus x squared. So, 64 minus 25 is equals to 39. So, 39 is equals to x squared. X is equals to square root of 39, or approximately 6.24 centimeter, or x is 6.24.
Nice! And now, we are done with Teacher Jelly's special triangles. And let us proceed to quadrilaterals. every quadrilateral has 4 sides with 4 interior angles. The measure of interior angles adds up to 360 degrees. Unlike the special triangles, its measures only equates to 180 degrees. And take note that quadrilateral equates to 360 degrees. Okay, so just like the special triangles, a quadrilateral also has 4 types. So the types of a quadrilateral are rectangle, square, parallelogram, and trapezoid. First, what is a rectangle? A rectangle is a quadrilateral with 4 sides. Opposite sides of a rectangle are parallel and congruent, and the 2 diagonals are also congruent. And we have in here a figure of a rectangle, and we all know what a rectangle is. In here we have the sides B and B. So these are labeled B because they are both parallel and congruent. And the width A and A. They are called A because they are both parallel and congruent. Okay, so as an example, we have in here rectangle ABCD. Take a look. So, the sides AD and BC are parallel and congruent. Meanwhile, the sides AB and DC are also parallel and congruent. However, the diagonals BD and AC are opposite sides. However, the diagonal AC is congruent also to diagonal B and D. And next type of a quadrilateral is the square. So, take a look in the figure. As we can see, a square is a rectangle with 4 congruent sides. So, all sides of the square are congruent with its interior angle that all equates to 90 degrees. And take note that if we add all these 90 degrees, it equates to 360 degrees. And the third one is the parallelogram. What is a parallelogram? Class, a parallelogram is a quadrilateral in which pairs of opposite sides are parallel. Pairs of opposite sides. Take note. So, in a parallelogram, opposite sides are congruent, and the opposite angles are also congruent. So, take a look in our figure. We can see in here parallelogram PQRS. So, look at this. The sides PQ and SR are parallel and congruent. Also, the sides QR on the top and PS in the bottom are parallel and congruent. And for their angles, angle P and angle R are congruent, and angle Q and angle S are also congruent. Okay, so lastly, the last type of a quadrilateral is the trapezoid. And to define, a trapezoid is a quadrilateral in which 2 opposite sides are parallel. 2 opposite sides are parallel. So, in correction, opposite sides in a trapezoid are parallel. So, the opposite sides are parallel. So, take a look in our figure. So, we have in here a trapezoid KLMN. In trapezoid KLMN, opposite sides or the horizontal sides KN and the other side LM are parallel to each other. Okay, class, very good. And we are done defining the 4 types of quadrilaterals, and we are up to deriving the area. So, we have in here area, the big capital A or the capital letter A denotes the area. So, area or A is equals to BH. For all parallelograms, including rectangles and squares, the area is equal to the product of the length of a base and the corresponding height. So, the A, which is equal to the area, is equals to B times H, the base multiplied to its height. That is the formula in deriving the area of our parallelograms, including rectangles and squares. Okay, class, for our application, take a look in the figure. We have 2 figures given in here, a rectangle and a parallelogram. The first one is a rectangle. The rectangle has a side of 10 and its base is 6. So take note that in a parallelogram or in this formula, you can select any of its base. So we have to apply the formula A is equals to BH and substitute the given in the formula. So we have the given 10 and 6. So area is equals to 6 multiplied to 10. And 6 times 10 is, yes, very good, 60. And to summarize, the area of this rectangle is 60 and followed by its unit. Second is the parallelogram. So, identify the given first. The given one is 8, its height, and 20, its base. So, substitute the given to the formula. Area is equals to 8 times 20. And we all know that when 8 is multiplied to 20, that equates to 160. So, the area of this parallelogram is 160 followed by its unit. Okay, so for the trapezoid, we have a different set of a formula. So, the area of the trapezoid equals half the product of the sum of the lengths of the 2 bases. Take note, 2 bases. These bases are parallel and the corresponding height. So, we derive the formula A is equals to 1/2 multiplied to its base 1 added by base 2 and multiplied to its height. Okay, for our application and to test whether you have understood my discussion, let us apply our understanding in this formula and figure. So, take a look. We have in here a figure of a trapezoid. So, first, identify the given. So, the first one is 10, 18, and its height is 7.5. So, base 1 is equals to 10, base 2 is equals to 18, and its height is 7.5. Next, we have to substitute this given to the formula. And we have to recall the formula. A is equals to 1/2 of the product of bases, the base 1, the sum of the bases, the base 1 and the base 2 multiplied to its height. So, the area is 1/2 base 1 plus base 2, which is 10 plus 18, times its height, the 7.5. So, the area of this trapezoid is 105. Very good.
Thank you very much, Teacher Ray.
You're welcome, Teacher Jel.
And now let's proceed to circles.
Let's go!
Given a point 0 in the plane and a positive number r, the set of points in the plane that are a distance of r units from 0 is called the circle, wherein the point 0 is called the center of the circle.
Okay, that was nice, Teacher Jel.
Thank you, Teacher Ray.
Okay, from Teacher Jel, I was able to learn from her that the center of the circle is the point 0. What else are we going to do right now, Teacher Jel?
What else? We're going to define the parts of a circle.
Wow! Let's go! So, are you familiar with the saying, life is just like a wheel, and a wheel is a circle, meaning our life evolves dynamically. And just like the circle, we also have different parts, and these parts have individual roles to partake. And the circle has many or various parts as well. And now, we are going to enumerate and define them all.
Class, first, the radius. A radius is any line segment joining a point on the circle and the center of the circle. Next is segment. A segment is a region bounded by a chord and the intercepted arc of the circle. Next is arc. Arc is the part of a circle containing the 2 points and all the points between them. Next is chord. Chord is any line segment joining 2 points on the circle. And the circumference is the distance around the circle. And the diameter is a chord that passes through the center of the circle. Tangent is a line that intersects a circle in exactly 1 point. And this one is a circle with its center and radius. Class, take a look. In the geometry figure on the right, 0 is the center of the circle, R is the radius, PQ is a chord, and ST is a diameter. An entire circle is considered to be an arc with a measure of 360 degrees, and that is the central angle associated with arc ABC measures 50 degrees. And that is all for the parts of a circle. Am I clear? Crystal clear.
Okay, thank you so much, Teacher Jel, for defining the parts of the circle and teaching us any other information regarding the circle. And we are all ready for the post-test. Okay, so class, please listen to the instructions. So, this test is entitled Go Game, and you are allowed to work with your groups. So, I have already grouped you in your corresponding groups with 5 members, and this is for your instructions. With your group, answer the following post-test by illustrating your answers in the writing words provided by the following of the instructions further. So, after I tell you the questions, so there will be an instructions for me to accept your answers. So it could either be dance all the way to me to tell me your answers, or sing any song that I wanted you to sing. Am I understood? Okay, let's proceed. So, this is in continuation with our pre-test. And presenting to you question number 6. We have in here the given. And it is an isosceles triangle. We have 13 centimeter and 10 centimeter. What do you think is the value of the missing number? Okay, very good. The value of the missing number is 13 centimeter. Why? Because an isosceles have 2 equal sides. Question number 7. The given is equilateral triangle. And the measurement of the first side is 16 centimeter. What do you think is the value of the missing number? Yes, very good. 16 centimeter. This can be explained because equilateral has 3 equal sides. Question number 8. Right triangle. The given in here is 45 degrees and 45 degrees. What do you think is the measure of the last angle? Very good. 90 degrees. All right angles measures 90 degrees. Question number 9. Rectangle. So, the measurement of the first side is 17 centimeter, and the height measures 12 centimeter. And what do you think is the value of the missing part? Yes, very good, 17 centimeter. Why? Because opposite sides of a rectangle are equal, meaning 17, and its opposite side is also 17. And for 12, its opposite side is also 12. Last question. Question number 10. The rhombus. So the given is only 25 centimeter. What do you think is the value of the missing part? Yes! Terrific! So in the rhombus, the figure or the measurement of the missing side is 25 centimeter, because this can be explained by the fact that all sides of a rhombus are equal. And finally, for our last question, question number 11, we have here square, and the given 90 degrees. What do you think is the measurement of the missing angle? Terrific! So, the missing angle measures 90 degrees. Why? Because all interior angles of a square measures 90 degrees. Thus, every angle forms a right angle. Okay, very good. All of the groups garnered a perfect score. Whew. Finally, Teacher Jelly, we are done discussing to them the
special triangles, quadrilaterals, and the circles.
Okay, Teacher Jelly, what can you say to our students?
Students, you deserve a fireworks applause. Okay, follow me. 1, 2, 3. 1, 2, 3. Tigs, tigs, tigs. Okay, all together. 1, 2, 3. 1, 2, 3. Tigs, tigs, tigs.
Nice!
Presenting to you the assessment in special triangles, quadrilaterals, and circles.
Nice! Since Teacher Jelly already presented the assessment of the 3 subtopics, so here is the summary of the lesson.
This handout consists of the basic knowledge in the following matters: special triangles, quadrilaterals, and circles. Henceforth, the lesson aims to give a briefly elaborated yet concise definition of the above-mentioned focus and identify its corresponding types, triangles and quadrilaterals, and parts of the circle. More so, with the knowledge on the concepts, a systematic and mathematical skills is to be gauged from the student using the process and formula resulting to an outcome.
It has been mentioned that there are 3 special triangles, namely equilateral, isosceles, and right triangle. In addition, each can be distinguished in the process of getting its missing correspondence, by which learners get to apply A plus B plus C is equal to 180 degrees, and the said Pythagorean Theorem. Ultimately, quadrilateral as well as 4 different types, namely rectangle, square, parallelogram, and trapezoid. In getting its area, you can simply multiply its base and height, except for trapezoid. Lastly, circles have the most parts, wherein each part are most commonly generated by an existing line. In lieu of the stipulated objectives, learners will counter real-life comparisons and contextual reinforcement of the lesson in order to attain an effective and productive discussion. And indeed, that was a wrap. Thank you so much for listening.
And thank you so much for your participation. And always remember,
that together, we can be better.
And I am Teacher Jelly.
And I am Teacher Ray. Thank you so much and keep safe.